This video is a brief review of the properties of exponents. When you multiply two expressions with like bases, you add the exponents. So x to the 5th power times x to the 7th power will be x to the 12th power. This makes sense because x to the 5th power is really 5 x's being multiplied together, and x to the 7th power is 7 x's being multiplied. So if you multiply 5 x's times 7 x's, you really have 12 x's all being multiplied together, which is x to the 12th power. On number 2, don't make a silly mistake and think that you're going to multiply 4 times 4 and make 16, and then maybe add the exponents and get the 11th power. It doesn't work that way. When you multiply two expressions with like bases, you keep the like base and you simply add the exponents. So this will stay a 4 to the 11th power. This makes sense because 4 to the 4th power is 4 4s multiplied together, and 4 to the 7th power is 7 4s multiplied together. Put it all together and you have 11 4s multiplied, so that's 4 to the 11th power. Number 3, x to the 5th power times x to the 8th power makes x to the 13th power, and y to the 3rd times y squared will be y to the 5th. Next we have the power of a power property. When you raise a power to a power, you multiply those exponents. So x to the 3rd power raised to the 5th power will be x to the 15th power. Similarly, 2 to the 6th power raised to the 3rd power will be 2 to the 18th power. When you raise a power to a power, you multiply. On number 6, because we have a power raised to a power, we will definitely multiply these and get 4 to the 4th power. However, notice that the negative sign goes away. When you raise something to an even power, a negative becomes a positive. Notice that if we were to raise something negative to an odd power, the negative would stay. So we would multiply the two exponents and get 4 to the 6th power, but the negative sign would still be there. Next we have the product to a power rule. When you raise a product to a power, you raise each factor to that power. So if we have x squared, y cubed, all raised to the 3rd power, we have to do x squared to the 3rd power, and then y cubed to the 3rd power. We just learned that when you raise a power to a power, you multiply. So x squared to the 3rd power will be x to the 6th power. Next we have to raise y to the 3rd power to the 3rd power. Again, a power to a power, you multiply. So this will be y to the 9th power. On number 8, I'm going to save the 2 in the front for last because that's the source of a common mistake. If I raise x to the 7th power, of course that will simply be x to the 7th power. If I raise y to the 6th power to the 7th power, we have a power to a power, so you multiply. That will be y to the 42nd power. A common mistake with the 2 and 7 is to put a 14. We get carried away with the multiplication. A power to a power, you multiply. 6 times 7, 42. So won't we have 2 times 7 is 14? No, because 2 is not a power. This is not a power raised to a power. This is just a number being raised to a power. In other words, this is 2 to the 7th power. It is not 2 times 7. So we can simply write 2 to the 7th power like this. Number 9 is really a combination of rules. Let's take it one part at a time. We have to raise x to the 3rd power, so that is x to the 3rd. Y to the 3rd power, so we have y cubed. Now let's move on to the second part. When we raise a power to a power, you multiply. So we will have z to the 10th power. Next we have the quotient of powers property. When you divide two expressions with like bases, you subtract the exponents. So x to the 5th power divided by x to the 3rd power will be x to the 2nd power. That's 5 minus 3. This makes sense because x to the fifth power is really 5 x's all multiplied together, and x to the third power is 3 x's. So the 3 x's in the denominator will cancel out 3 of the x's in the numerator, leaving behind 2 x's multiplied together, or x squared. I'm going to show you 2 different ways to do number 11, and you can decide which way is best for you. Do not cancel out these 3's and put a 2. It doesn't work that way. Remember, when you divide with like bases, you subtract the exponents. This is like 3 to the 1 power. So 3 squared divided by 3 to the 1 power is just going to be 3, because 2 minus 1 is 1, and 3 to the 1 power is just 3. Anyway, when we divide x squared by x to the fifth power, 2 minus 5 is negative 3. So that's going to be x to the negative 3 power. We're not done, but I'll come back to that. Y to the fourth power divided by y squared. 4 minus 2 is 2, so that leaves y squared. We cannot leave negative exponents in the answer. The fact that we have a negative exponent means that the x belongs in the denominator. So we drop the x down to the denominator and make the exponent positive. So this is the final answer. Here's another way to approach this problem, and to be honest, this is the way that I prefer to do it. Picture this in your mind. You wouldn't really write this down, but 3 squared is 3 times 3, x squared is x times x, well, etc. You see where I'm going with this. If we have 2 3's in the numerator and 1 3 in the denominator, the 1 3 in the denominator will cancel out one of the 3's in the numerator. That's going to leave behind a single 3. We have 2 x's in the numerator and 5 x's in the denominator. So the 2 x's in the numerator will cancel out 2 of the x's in the denominator, leaving behind 3 x's. So that's going to leave x to the third power in the denominator. We have 2 y's in the denominator, which will cancel out 2 of the y's in the numerator. That leaves behind 2 y's in the numerator, so y squared. Either way, you get the same answer, so whichever method works best for you. I'm going to solve problems that second way because that's what I'm more comfortable with. So the x in the denominator will cancel out one of the x's from the numerator. So that's going to leave behind a single x. And then when it comes to the y's, the 7 y's in the numerator will cancel out 7 of the 10 y's in the denominator, leaving behind 3 y's. So that's y to the third power left in the denominator. Or you could subtract the exponents and get this, which leads back to this. Next, we have the power of a quotient property. When you have a fraction raised to a power, you simply raise the numerator to the power and the denominator to that power. So x squared over 5 to the third power, we will do x squared to the third power. That's a power to a power, so you multiply. And we get x to the sixth power. In the denominator, we will simply raise 5 to the third power. So we can just write 5 cubed. By the way, 5 to the third power is 125, so we could write the answer like this as well. Anyway, on number 14, we have to raise the numerator to the fourth power and the denominator to the fourth power. A cubed to the fourth power is a power to a power, so we multiply these and we get a to the 12th power. And then we have b squared raised to the fourth power. This is a power to a power, so we multiply these and get b to the 8th. On number 15, our lives will be easier if we simplify the expression on the inside before cubing it. So x to the 7th power divided by x to the 5th power will be x squared. We are subtracting these, or we're canceling these out, whichever way you want to look at it. Y to the 3rd power divided by y will be y squared. And then we have all of this raised to the 3rd power. So a power raised to a power, you multiply. This gives x to the 6th power and y to the 6th power. Kabam! I mentioned this briefly before, but if you have an expression raised to a negative power, you move that expression to the other side of the fraction and make it a positive power. So if I have 5 to the negative 3 power, I'm going to take this expression and drop it down to the denominator. So I'm going to have 1 over 5 to the positive 3 power. I'm going to show you two different ways to do number 17. Both expressions have a negative exponent. That means that both expressions need to be moved to the other side of the fraction bar. So my new fraction will be x squared over x to the 5th power. We moved them both and turned the exponents into positives. Now we can simplify as we have on previous problems. The two x's in the numerator will cancel out 2 of the x's in the denominator, leaving 3 x's in the denominator. When there's nothing in the numerator, we need a 1 as a placeholder. After all, when you're canceling out things that are the same, something divided by itself is really a big old 1. So it makes sense that you're going to have a 1. The other way to do this problem is to use the property that says when you divide with like bases, you subtract the exponents. So be careful. I'm going to show this step. You would normally do this in your head, but we are subtracting negative 5 minus negative 2. Negative 5 minus negative 2. Notice the double negative. So this is the same thing as x to the negative 5 plus 2, which gives x to the negative 3 power. So you normally wouldn't write down the first two steps. You would just do this in your head. But in the end, we need to drop this down to the denominator because of the negative exponent. So we end up with 1 over x cubed. I like the first method better, but some students will prefer to do it this way. Whatever makes you happy. For number 18, let's simplify the inside part first. The 3 in the numerator will cancel out one of the 3's in the denominator, leaving behind a single 3. The 2 x's in the numerator will cancel out 2 of the x's in the denominator. That's going to leave behind 3 x's. So we have 1 over 3x to the 3rd power, all raised to the negative 2 power. Quick side lesson. If you have a over b raised to the negative 3 power, you can do the reciprocal and write b over a to the positive 3 power, and then go from there, and of course we will have b to the 3rd power over a to the 3rd power. The thing I want to emphasize is that if you have a fraction raised to a negative power, probably the easiest thing to do is to make the reciprocal and change the exponent to a positive. So I can take the reciprocal of this fraction and make the exponent a positive 2. Of course, we don't really need the 1 in the denominator. So now we have this. Again, be careful with the 3 and the 2. Don't get carried away with all this multiplication. This is not a power to a power. This is just a number being raised to a power. This is 3 squared. So put a 9. Now we have a power to a power. This is when you multiply, and you get x to the 6th power. Kabam!